Hi, here's the screencast for Lesson 4-2, Degrees and Radians in Precalculus. So first off, angles and their measure. An angle is defined as two non-collinear rays that share a common endpoint known as a vertex. So what it's talking about here is the fact that we can have two non-collinear rays, meaning they're not on the exact same line. They share a single endpoint. There we go. And then we know that there's an angle in between them. So here's my theta angle. The starting position of the ray forms the initial side of the angle. So let's say we started with this ray right here. This would be the initial side. And then where you end is called the terminal side. So here, this would be the terminal side, with the initial being the green. Anyway, you can kind of think of this like a terminal, a bus terminal is where you get off the bus at. It's where you end. I mean, this is morbid, but if you have terminal stage cancer, it's like the end, where initial always means starting. So an angle with its vertex at the origin is the standard position. So normally we start at the origin right here. So we always have our initial ray starting right here along the origin on the x-axis. And then if you go up, you have a positive angle. And so this is an example on the right side of an angle in standard position. So you can see the initial side is where we start, this terminal is where we end, and then we always go in a counterclockwise fashion for a positive angle. However, you can have a negative angle, meaning you start at the origin and then you go clockwise. So negative angles are clockwise, positive angles are counterclockwise. Units. 1 unit measure for an angle is a degree. 1 degree is 1/360th of a full rotation from the initial side. So you can have a degree measure of 45. You can have a degree measure of, let's see if my terminal is right here, it'd be like 150. And you can have an angle measure that goes all the way around. And if it ends up back at the origin, you could say its degree was 360. So angles can also be measured in radians. So it's called rad. So on your calculator, at the top of your calculator, you'll see something that says DEG for degree, or you can see that it says RAD, rad, for radian. So the measure degree in radians of a central angle of a circle is equal to the ratio of its length, blah, blah, blah. What this means is the measure of theta in radians is going to be equal to the ratio of the length of the arc that's traced out of the circle divided by the radius of the circle, because 1 radian is equal to 1 radius length, but the radius length will be laid out along the outside of the circle. So I'll show you a little bit of that later. So you can say theta, the angle, is going to be equal to the arc length divided by the ratio. The radian. So it's the ratio of the arc length divided by the radius. So a central angle is a measure of 1 if the radian intercepts an arc with the same length. So that would be, let's see, this long of a radius, maybe this long of the arc. So this length would be the same as the radius. You would call that 1 radian. All right, so a full rotation around a circle takes us a distance equal to the circumference, 2 pi r. So this is the distance around a circle, is the circumference. And we already know the length of the circumference, due to other math, is 2 pi r. So we know that 360 degrees is going to equal to 2 pi r divided by r. Because remember, the angle in radians is going to equal the length of however long your arc is here. The arc would be 1 complete trip around the circle divided by the radius. So when I divide by the radius, the r cancels out. So we know 360 degrees is going to equal to 2 pi. So that's what this is saying. 360 degrees is equal to 2 pi, 180 degrees is equal to pi. So if we want to convert a degree measure to radian, so you have your number of degrees, your angle in degrees is going to be equal to pi radians divided by 180. And the reason we're dividing by 180, one way you can think about it, is so we can cancel out this degree measure and we'll be left with units of radians. Another way to think about this, you're actually going to multiply. You multiply by this. So if you want to go from radian to degree, so radian to degree, you take the number of radians, multiply by 180 degrees, divided by pi radians. So the reason we're using 180 and pi is because if 360 equals 2 pi, divide by 2 on both sides, we know 180 will equal pi. So we want to convert the following from degrees to radians. So we have 135 degrees, multiply by pi radians, divided by 180 degrees, and we get that is equal to 135 pi divided by 180. Well, there's a common factor. Here, the common factor is 45. 45 goes into 135 3 times. 45 goes into 184 times. So we end up with a measure of 3 pi over 4 radians. Next one, we have minus 30 degrees multiplied by pi radian divided by 180 degrees. So this is just called your conversion factor. So this is how you convert. So we get negative 30 over 180 pi radians. 30 is a common factor. So 30 goes into 1s here. 30 goes into 6 here. So we have negative pi over 6 radians. And so remember, you can have a negative angle. All that means is it's going to go in the clockwise direction. So negative angle here would mean a negative going down clockwise direction. Right. Now let's convert the following from radian to degree. So we have 2 pi divided by 3 radians. Okay, so we multiply by 180 over pi radian. So you notice right away the pi are going to cancel out. And we get 360 over 3. You simplify that, you get 120 degrees. The next one, negative 3 pi over 4. So I multiply by 180 degrees over pi radians. And how I remember what to put on top and bottom, if I want degrees, I have to have that on top. If I want to get rid of radians, what I currently have, I have to have that on bottom, so it'll cancel out. So I have 3 times 180, well, don't forget the negative. So negative, 180 times 3 is going to be equal to 540. Divide by 4, the pi's cancel out. So 540 divided by 4 is going to equal 135 degrees. 135 degrees, don't forget the negative. Hey, let's double check our answer is correct. So up above here, we had 135 degrees is equal to 3/4 radian, 3/4 pi radians. Here we had negative 3/4 pi radians, which means we'd have a negative 135 degrees. Cool, so we double checked our answer. So more fun with radians. If pi is equal to 3.14, half of that you just divide, 1.57, 2 pi you just multiply, 6.28, and so if you have 3 pi over 2, multiply pi by 3, divide that by 2, you get 4.71. So another way to think about it is if we know the whole, going around the whole circle is 2 pi, going around half would be pi, and if you want pi over 2, you would go half of the previous one, which is only 1/4. And then pi over third, what this is showing is, well, you know pi is over here to the left, so you go 1/3 of the way, and this is an angle measure of pi divided by 3. So real quick, let's double check that we understand that all of these have degree equivalents. So this is a 360 degree. This is 180. Let's see, half of 180 would be 90 degrees, which is what this shows. This shows a 90-degree angle. And then 1/3 of pi, meaning 1/3 of 180, is a 60-degree measure. Cool. So you could say pi over 3 radian is going to equal 60 degrees. So visually, I would say this is the most important picture so you can really understand it. So we start here, and we can start counting. So here's 1 radian, 2 radian, 3 radian. Remember, radian just means the length of the radius. 4, 5, 6 radian with this little bit left over. The amount that's left over right here is equal to 0.28 to blah, blah, blah. Because this is 2 radian, and remember, 2 times pi, 2 pi is equal to 6.28. So I have 1, 2, 3, 4, 5, 6.28. So 1 radian is equal to 180 degrees divided by pi, which is 57.3 degrees. That's not very useful, but that's just a little fun fact. Fun fact. Okay, so coterminal angles. What if we have 2 angles that have the same initial ray and same terminal ray? Well, one of them is going around positive. Here's the positive one. And the other is going around, and it is the negative ray. So you call them coterminal. Coterminal. So like if you're co-managers, you're sharing the responsibility. If you're co-workers, like you're working together, here coterminal means you're sharing the terminal ray. So not only can you have a positive and negative have the same coterminal, but you can have 2 positive angles sharing the coterminal. So one just goes from the initial to the terminal, and the other goes all the way around once and then keeps going till you have that ray. So if I know the angle of alpha, right, so that's all this character is alpha, here's beta, this just means the first angle, this just means the second, so I know the angle measurement of beta, it's going to be the alpha measure, whatever this is, plus 360 degrees, because I went around one complete turn, and I went around one complete turn before I went up to my final terminal. In the same way, you can have 2 positive coterminal angles. You also can have 2 negative coterminal angles. So I can have one guy goes here, and then I can have another that goes all the way around. And of course, if you want to get crazy with it, you can have one that goes multiple times all the way here. It's just every single time you make one complete loop around, you have 360, 720, etc., etc. So in order to take that into account, in order to write that you have to say 360 degrees every time you go around the circle once again, you can say that you want to add or subtract multiples of 360 or 2 pi, 360 degrees or 2 pi. And this is to find coterminal angles. So in this example 3, identify all angles which are coterminal with the given angle. Then find and draw one positive and one negative angle coterminal with the given angle. So the first example is 80. So first off, if we want to identify all angles which are coterminal, what we can do is add or subtract 360 degrees. So what this does is we can have an angle of 80 degrees, so that's going to be right here. So going from the initial to the terminal, that's one way. But another coterminal angle is if I go all the way around here, so that would be 80 degrees plus 360. I also can have another one that goes from the initial all the way around here, or all the way around twice. So that would be 80 minus 360, the first one would be. That would be 80 minus 360. And then of course you can do, you'd have to do multiples of the 360. Cool. So we have to give an example of a positive. So let's, as I was talking about, the positive would be 80 plus 360. So to draw that, I would say, okay, that's equal to 440 degrees. 88 degrees is about right here. So you go from the initial to the coterminal, let's see, to the terminal side, and then these are going to be two coterminal angles. So the first one goes from the initial to the terminal, and of course we want the positive. That means it's going to go, so this positive 440 will go around one whole time to 360 and then keep going to the 80. So that would be a total of 440 degrees. The negative one would look something like this. So we have 80 minus 360. That would be negative 280 degrees. So I start at the initial and I go around to the terminal. So hopefully you can see the colors and you can see the difference. So the negative would look like this, where the positive looked like this. So it totally depends which way you're going. So remember, positive means you are going counterclockwise. Negative means you are going clockwise. Alright, so let's try it. That was with degrees. Now we can try with radians. So once again, if you're going around multiple times, you will add or subtract, oh my god, I can't even read that. Add or subtract multiples of 360 or 2 pi. So what I want to do, so I can take into account all angles, so I want to add 2 pi, but also I could subtract 2 pi. So I have plus or minus 2 pi. Alright, so let's try the negative one first. So this would be negative pi over 4 minus 2 pi. So when I do that, I will get, let's see, over 4. So this will actually be 8 over 8. Let's see, let me just convert it. So negative pi over 4 minus 8 pi over 4. Yeah, because that would be 2 pi. So that'd be negative 9 pi over 4. Cool. Another way to say this is 2 and 1/4 pi. Let me draw this out. Alright, so here's my initial ray. Let's see, so my original was negative pi over 4, so that means it would be right here, going down. I apologize, I made a little mistake. This should have a negative inside. Alright, so negative 2 and 1/4 pi means it goes around all the way once and then goes down by 1/4. So those are coterminal because they have the same start and the same end. So now I'm going to do the positive one. So positive, so I have negative pi over 4 plus 2 pi, so here it'll have the same. Well, we still have negative pi over 4. I want same numerator denominator. That way I can actually add these fractions. So it'll be 8 pi over 4. You add these together, you get positive 7 pi over 4. Let's see. So this amounts to 1 3/4 pi. So if I start at the initial ray, I go around. Let's see, this is 1 pi. Here's 1.5 pi, 1 3/4 pi. So you can see all three of these, the negative pi over 4, the 1 3/4 pi, and the negative 2 and 1/4 pi, all have the same initial and terminal rays. Okay, next is applications with angle measures. So we already learned before that in radians, the amount of radians is the arc length divided by the radius. So if I come back down here, if I want to solve for arc length, we said the angle in radians is equal to the arc length divided by the radius. So if you multiply by the radius on both sides, you'll get arc length by itself. Here, you know the arc length is just the radius times the angle in rads. So you can kind of think of this as like the good way to think about this is the length of crust on a pizza. On a pizza slice. That's what we're talking about when I say the length of the arc. I want to point out that this theta must be in radians. So for example 4, when it says find the length of the intercepted arc in a circle, aka the length of crust on a pizza slice, with the given central angle and radius of 125 degrees, with the radius of 7 centimeters, we need to convert that angle into radians. So we need to convert first. So 125 degrees multiplied, well, I have to get rid of the degrees, so I put degrees on bottom. And then the same thing as saying 180 degrees is pi radians. So when you multiply by this, you get 25 pi over 36. So I just simplified first. All right, so I want to know the length of the arc, the length of the crust. So I use the length of the arc is going to be equal to radius times the amount in radians. So the radius is 7 centimeters multiplied by 25 pi over 36. Yeah, this is not going to be a nice number, so I'm just going to give it to you in a decimal. So this will be 15.3 centimeters. Cool. All right, so we found how to measure the length of this, but now we want to measure the area. So the area of a sector is 1/2 radius squared times the angle. And so how do we get that? How do we get the area? And keep in mind, this theta is measured in radians. So secretly, this formula comes from the fact that the area is equal to 1/2 radius times the length of the arc. So the length of the arc is the radius times the amount in rads. So of course this simplifies to 1/2 r squared theta. So basically this is like a triangle where you have 1/2 base times height, more or less. That's, you can look in your book for more information. All right, last example. Number 5, find the area of a sector. So we're looking for area of the sector with a given central angle and radius. Oh my gosh, why do they do this to us? Notice that we have angle, but we have to convert to rads. Convert to radians. Okay, so 60 degrees. I have to get rid of the degrees, so I multiply and make sure the degrees are on bottom, so that way they will cancel out when I multiply. I'm just going to go ahead and simplify. 60 can go into 80 3 times, and of course, don't forget to write your conversion factor. 180 degrees is the same as pi radians. So this will actually equal pi over 3. So our angle in radians is pi over 3. Okay, so let's use the equation given for area. A equals 1/2 r squared times the angle. We know the radius is 8 feet. So go ahead, plug in 1/2, 8 squared times pi over 3 radians. So we get, let's see, 8 times 8 is 64. So 64 divided by 2 times pi over 3. This gives us, let's see, 32 pi over 3 feet squared. That's acceptable, but you also can simplify by putting in a calculator, and you can say 33.5 feet squared. So one application of the formula for arc length is circular motion. So you can talk about linear speed, which is the rate at which objects move along a circular path, or you can talk about angular speed, the rate at which objects rotate about a fixed point.